The highest form of pure thought is in mathematics. Plato. We want to solve AMC problem American Math Competition 12B last year 2021, but we don't want only rich solution. It's good to consider intuitive thinking, paying attention to diagram. All these things are useful for solving a problem. At first, you can use programs to graph this diagram, and after that you can imagine these things. For example, look, the functions are what? X to the power of 2 to the power of root 2. It is a polynomial. And can you guess brown or blue, which of them is the left hand side? Pause the video and try. The left hand side will be what? Blue one, because the right hand side is exponential and the growth after some number will be so much higher right hand side. So right hand side will be brown and left hand side will be blue. So also you can imagine, let's jump into the problem. It says let S be the sum of all positive real numbers x, for which x to the 2 to the square root of 2 equal to root 2 to the 2 to the x. Which of the following statements is true about S less than root 2, equal to root 2, greater than root 2, less than 2, greater than equal to, less than 6, and S is greater than equal to 6. So we don't need to find exact answer. We want to find the interval, the bound for S, sum of the roots. So let's start this problem. Before starting this problem, I should say something about logarithm. If you know them, we can use the time codes to pass. But I think if you also know log, maybe you don't know, for example, something that I want to say. There are around 15 important rules in logarithm. If you know them, you can solve any problem from qualifying level up to IMO. And I will tell only the things we need here. If you want to know all of them, feel free to send message to my WhatsApp number in the description. So the first thing, log a b. Pay attention to this. You should say b, ask this question from yourself. B to the power of what? To the power of what is a? Then the answer of this will be log a b. B to the power of what is a? So for example, log 8 2. You should ask this question. B is 2. 2 to the power of what is 8? 2 to the power of what is 8? 2 to the power of 3. Or for example, if you have log root 2, or let me write it's better, 2 root 2 2 in base 2. It is, we want to find this. You ask again this question. 2 to the power of what is 2 root 2? Then you should simplify. It will be 2 times square root will be 2 to the power of 1 over 2. It will be 2, 1 plus 1 over 2 equal to 2, 3 over 2. So 2 to the power of what is equal to 2 to the power of 3 over 2? Exact, 3 over 2. So it is the definition. You can ask this for logarithm problems. Now, the first rule is this. If you have a log a to the power of m in base a, it is what? Can you say? Pause the video, ask the question. Yes. A to the power of what is a to the power of m? A to the power of m is a to the power of m. So first one. Second rule, if you have log a in to the power of mb, you can take m outside and write this. Log a in base b. You should memorize second one. Third one, log a, for example, c in base b. It will be what? You can change it to plus log a base b log c b. So we need these three rules for solving the problem. Let's start. X to the power of 2 to the root 2 equal to root 2 2x. Now, when we want to solve a problem, for example, logarithm anything, there are some rules in many books you can find, but there are some ideas. Most of the time, you don't see ideas in the, for example, in books, in sites. But how can you find the ideas? You should solve many problems and then gather the common points in each problem, and then you will see, okay, every year that you see logarithm, it will be solved with this idea. or this idea, or this idea. You will find three important ideas that 90% of logarithm problems can be solved by that. These are ideas. So because I solved many problems, I've gathered some important ideas, for example, for logarithm and other topics, geometries. If you want to know them, feel free to send message to my WhatsApp number. So let's start. One thing, when you see these things, you have powers, x in the power. The idea is take a log from both sides. This idea is useful. I can say there are 2 or 3 important ideas, basic. In logarithm, one thing is this: when you see x in power, you should do this. Now, in what base? Now I have question, in what base? Because we have x, you can write log in base x. We have root 2, you can write in root 2. But because root 2, you can do it and you can reach the solution. But 2 is better. And then you will see why. So let's take log in base 2 from both sides. So it will be what? Log 2 here x to root 2 equal to log root 2 to x in base 2. Now let's focus on right hand side. It will be what? It will be log 2, you can write instead of root 2, 2 to the power of 1 over 2 times 2 to the power of x. And then we can write what? You can write 2, 1/2 times 2x. And it will be what? It will be 2 here, 2x over 2. It will be 2x minus 1. It is right hand side we've simplified, and then you can say it is what? The definition of logarithm in the part in the beginning of the video I said. 2 to the power of what is 2 to the power of 2 to the power of x minus 1? You can write also like this. 2 to the power of what is 2 to the power of 2 to the power of x minus 1. So here it is this. So we can write 2 to the power of x minus 1. Let me erase this part. So I found this. Now let's simplify left hand side. So if I want to focus on left hand side, I can say log x to the power of 2 to the power of root 2 in base 2. I said a rule in the beginning. Here it is log AM. You can take m in front of logarithm. So here I use that rule. It will be 2 to the power of root 2 log x in base 2. So here I conclude 2 to the power of root 2 log x 2 equal to 2 x minus 1. Now again we have x in our powers. So what can we do for get rid of this? I told you the idea. Yes, we should take log. But log in what base? Because here we have 2, we consider log in base 2. So I consider log 2 root 2. Log x in base 2. Here in base 2. Now, it is a log 2x minus 1 in base 2. By the definition, 2 to the power of what is 2 to the power of x minus 1? So it is what? X minus 1. Let me erase this. Now let's focus on left hand side. I want to simplify that. You can say, okay, it is, if you pay attention, you take a log from this. And here we said it is this times this. And we said when we have product here, log AC in base B is log A in base B plus log CB. Now if I apply third rule here, it will be log 2 root 2 in base 2 plus log what? This one. Log x2 in base 2. Now here, I want to find this. It is what? 2 to the power of root 2, 2. You can ask yourself the question, 2 to the power of what is 2 to the power of root 2, you can easily answer. This one will be root 2. So it will be root 2 plus log x 2 here. Now, let me erase this part. If I simplify, the left hand side is this, so I write root 2 plus log x 2 equal to x minus 1. Then, if I take root 2 to right hand side or subtract root 2 from both sides, you can say both of them are same. X minus 1 minus root 2. Now, I want to find what x's satisfy this. If we check some numbers, we can find one root of this. If we check, for example, 2 here, let's consider, I say x log x 2, and this function x minus 1 minus root. Look, this part should be positive. So, if we consider x equal to 1, it will be 0. But 2 to the power of 0 is 1. So after 1x1, it will be positive. Before x1, it will be negative. So we conclude x should be greater than 1. And now, if we consider start for 1, we said it is impossible. Now, let's start, for example, we can also check 2, but one number that is good between 1 and 2 and is related 2 to the power of what? 2 to the power of what is between 1 and 2? Pause the video and try at first by yourself. Root 2. So if you place 1, it doesn't have any answer, this one. This one will be 0 minus 2 negative root 2. For 0 also, we don't have any answer here, but it will be what? Negative 1 negative root 2. For this one, root 2. If you place it here, let me calculate this part and then I will erase. Log 2 log root 2 2. 2 to the power of what is root 2 1/2? And again ask the question, 2 to the power of what is 1 over 2? Negative 1. So here it will be negative 1. If we replace root 2 here, root 2 minus root 2 0, negative 1. So we found one answer. Now, let's check for 2 also here. For 2, if we check here, is easy. 2 minus 1, 1 minus root 2. And for 2 here, if we replace log 2, 2 2 to the power of what is 2, 1? 2 to the power of what is 1, 0. So here it is 0. And the next number is good to check. You can say, for example, 2 root 2, this number. But if you check 4, you can also check 2 root 2 if you want. But 4 is enough. When I tell the solution, you will understand. So if you replace 4 here, it will be 4 minus 1, 3 minus root 2. And if I replace 4 here, it will be what? Let me calculate. Log 2 log 4 2. 2 to the power of what is 4 2? 2 to the power of what is 2 1? So it will be 1. Now we've calculated the critical points that we need. So let's draw the function approximately. Okay, so let's consider these two functions. For example, x1, x2, x3, x4, and also let's consider negative 1, negative 2, negative 3 here. And if we consider x0, this one will be negative 1, negative root 2. It will be around, root 2 is 1.4, negative 2.4. It will be something like, let me draw with pink, something around this, and it is a line, this one. So here also, if I consider root 2 will be around this. It will be negative 1, so it will be something like here. Okay, they are approximately, and it's not important to draw exact figure. So I draw a line from between these two lines. And for 2, it will be what? For 2, it will be 1 minus root 2. So if I want to draw completely a little better, so for 2, it will be around 0.6. So it will be something like this. And here I can say, okay, for -1, for root 2, it will be something like this. It will be -1, for example, some point like here. And now we want to draw the second one. This one, let me draw with green. Log x 2, 2. So here we said for 1, after 1 it's possible. And if you draw this, let me draw with pink, it will be asymptote of this function. So I draw with this one, this. Okay. So it will be something like this, and the function will be like what? It passes through this, and it will be something like what? You can see for 2, for example, this function is 0. Okay. So for 2, if we want to draw, okay, so let me, for pink one, let's consider the x-intercept, y-intercept to draw exact figure, the approximate figure. For 0, it is what? -1, negative root 2, negative 2.4. And if you want to find x-intercept, 1 plus root 2. 1 plus root 2 is 1 plus 1.4 is around 2.4. So it passes through something like this. So it will be passed like this. And now if I want to draw the green function, I say, okay, it will be something like this. Vertical asymptote. It will be root 2 here, if we consider. And in 2, it will be 0. And now, let me tell you something. Here, if you pay attention, in 2, the green one is what? The green one is this log. The pink one is what? This one. Now, if I pay attention here, it is for root 2, they are equal. After that, for example, in 2 it is 0, it is negative because it is around 1.4, it will be negative 0.4. It will be less than this. So look, green one is greater and it's obvious in our figure. In 4, we can see what? Which of them is greater? It is around 1.4. It will be around 1.6. And this one is greater, pink one. So you will understand it will have some intersection between 2 and 4. Because in 4, green one is less than pink one. Now, one root is 2. One root is between 2 and 4. Okay, and you can say between these two because it is on top of this one green here, and here pink is on top of green one. You can use, we have theorem, obvious theorem, intermediate value theorem, that we have root here. And look, the growth of this line is greater than pink one, greater than green one. So after that, it grows more than green one, the pink one. So here we say, okay, one root is this, one root is this. So S is what? Is root 2 plus a, that is this interval plus a. So we can say it is greater than 2 plus root 2 and is less than root. If we, okay, S is sum of these two roots. The choices are this. So 2 plus root 2, this one. If we consider the cases for some S less than root 2 is wrong because S is greater than 2 plus root 2 and it is greater than this. S equal to root 2 obvious doesn't satisfy because root 2 is not greater than this. S less than 2 no, because S greater than 2 plus root 2. S is greater than equal to, yes, it is greater than equal to. Greater than equal to means it is greater than this or equal. Because it is greater than, it is okay. Less than 6, we can say it is around, it is less than 2. So 2 plus 4 less than 6. So D is correct. Also, let's reject E. It says S is greater than 6. Impossible because S is less than 6. So the answer is D. You can click on my playlists. I release many problems of Harvard, MIT math tournament, also other Olympiads from Singapore, Philippine, British Mathematical Olympiad, America, IMO international level. You can use them and you can step by step gradually improve your problem solving. If you had any question, there are some ideas in each topic, in each, for example, part, logarithm, algebra, combinatorics, geometry, number theory. There are some ideas that are useful, idea, not rule, that are in the books. Some important ideas that are common in many problems. If you want to know them and have any question, feel free to send message to my WhatsApp number in the description. If you've learned something new, don't forget to subscribe, turn on notification, like this video, and comment if you had any question.